Hello everyone and welcome. It wouldn't be a proper project car if there weren't some headaches along the way. So in this video we're going to be talking about my Miata, which has a supercharger, however it doesn't always have boost. Now if you haven't yet checked out my video on the install, you should definitely check out that video, and overall the supercharger install itself went great. So looking at it, it's an extremely clean appearance. Honestly, the first time you just glance at this engine bay, you don't even notice that it's supercharged. It's a very clean install. However, the unfortunate news is that it's not making any more power depending on the scenario. So first off, to illustrate the problem, I took my V-Box and I did some acceleration runs before and after installing the supercharger to see how much quicker the car would get. And so I did pulls in first, second, and third to see, what was the acceleration beforehand and what was it afterwards, not including gear shifts, all just in each individual gear, what was the acceleration. And so for example, for first gear, the average of a few runs from 10 miles per hour to 30 miles per hour was 1.8 seconds. In second gear, naturally aspirated before the supercharger went on, accelerating from 20 miles per hour to 40 miles per hour happened in 2.4 seconds on average. So then I put the supercharger on and I went out and did these same tests again. The first run I did in first gear, 10 to 30 miles per hour was 1.9 seconds. So 0.1 seconds slower than when it was naturally aspirated. I then did a pull in second gear from 20 miles per hour to 40 miles per hour, and it did that in 2.3 seconds. So 0.1 second faster than naturally aspirated. That didn't seem right, so I ran another second gear pull from 20 to 40. And this time it took 4.1 seconds. Much slower than when it was naturally aspirated. Okay, so clearly there's a problem. So this video was supposed to be the story of how much power my supercharged Miata makes and how the acceleration has changed and how joyful it is to drive. And yet here we are again with me sadly shifting in my garage. So in this video, we're going to be figuring out what's wrong with my Miata and fixing it. Now, starting off with the first time I drove the car, there were already a few issues that were immediately apparent. First of all, it was low speed throttle control, and I knew about this before even putting the supercharger in. There's plenty of discussion in the Miata forums talking about the low speed throttle control with this kit. And basically how it is that it's very sensitive to your right foot as you're going on the throttle and letting out that clutch. And so clutch engagement, especially in first gear as you're taking off, is very difficult to modulate. It can be done well, but it's very challenging and requires very sensitive use of your right foot. So I wasn't too worried about that because everyone talks about the Fab9 tune out there that fixes this issue. No worries, it's a tuning problem. I'm not worried about it. The next issue I found was from the drive home from Humble Mechanics shop, and so on the way back using cruise control, what I noticed is that if you started to go uphill and you're in sixth gear cruise control, it would keep going in and out of boost. And so you get this jolting of the car because it's accelerating and then saying, no, we don't need that much power, accelerating, then saying, no, we don't need that much power. And so you could feel the jolting and it just goes on, off, and it's pretty annoying in cruise control. And so if I turned cruise control off and just used my foot to modulate the throttle, well then the issue didn't exist anymore and you could easily modulate the throttle, stay at whatever RPM you needed to be, and you wouldn't have that jolting of that bypass valve closing and opening and giving you boost, no boost, boost, no boost. So again, this felt like a throttle issue, so I wasn't too concerned because it seemed like a software problem, not a hardware problem. Now we get to the bigger issue of not having any boost. So I was reading through Miata forums looking for other people that were experiencing this, literally not having any boost, and I was having trouble finding anyone that was having a similar problem. So that's when I started to think, okay, there's probably a mechanical issue here. And so I was trying to figure out a way that I could repeat not having any boost and then certain scenarios where it would have boost. And what I found is that if I floored it below 4,000 RPM in third or fourth gear, then it would have boost all the way to redline. But if I already had it up to maybe 4,000 RPM or above and I floored it, then I would never get boost all the way to redline. And so I was able to repeat that. Below 4,000, I'd get boost. After 4,000, if I floored it, I wouldn't get any boost. So why does it have boost sometimes and not others? And I think here's where a lot of people like to rush to judgment point fingers and say, you did something wrong, this company did something wrong, and create this pointless blame game. And it's extremely unwise to rush to judgment when you don't know absolutely everything about a scenario. And it can make you look quite silly when you're wrong. So I would urge you not to play the blame game and instead just focus on what's the problem? How do I fix it? So what I did is I took a laptop and I plugged it into my car and I read some data from the car to figure out what was going on. And what I found is at 3,650 RPM, when I floored it, I'd see the manifold pressure jump to about 0.8 bar, and then as it built boost, it would go all the way up to about 1.6 bar. Well, when I floored it at 4,800 RPM, what I saw is manifold pressure peaked up to 0.7 bar, and then it just simply declined from there, and it never built boost. And in both of these scenarios, flooring it at 3,650 and flooring it at 4,800, accelerator pedal position was at 100%. So what's happening? Well, here's what I initially thought, and I was wrong, by the way. So here we're looking at the supercharger. The air is coming in through the throttle body. It travels then through the root style rotors of the supercharger and then into the engine. Now you have a bypass valve right here, and there's a vacuum line attached to that bypass valve. So when it sees atmospheric pressure, the bypass valve closes and it forces a seal between this side of the supercharger rotors and this side, so you create boost going towards your engine. Now what I thought was going wrong is that right here, this valve wasn't fully closing. And so my accelerator pedal position was at 100%, so this was wide open, but then this wouldn't fully close. So it was acting as a restriction as the airflow passed through and tried to go into the engine. And because it was restricted and I didn't get a high enough pressure here, there wasn't enough pressure to then close the valve, and thus I couldn't get any boost. So I called Edelbrock to try and figure out what was going on, and they believed it was one of two things. Either it was the bypass valve somehow binding up, or perhaps there was a problem with the actuator for the bypass valve. So they told me to look over a few things on the car, but unfortunately, if everything looked good, sounds like I'm going to have to send in the entire unit so they can check it over and make sure it's not a faulty supercharger. Obviously that was pretty disappointing to hear because it meant my car was going to be out of commission for a while as the supercharger got looked over. Not to mention, it's not the world's easiest task to take this supercharger in and out. So I looked over the car and I found two pinched hoses, one of which was for the evap line, the other of which was for the brake booster. Now my brakes worked just fine, and the brake booster line wasn't actually pinched too bad, so clearly that one was still working. Regardless, I fixed that. I fixed the evap line so that it wasn't pinched, but none of these should really alter with the bypass valve. So then I took a borescope and I followed the line for the bypass valve to make sure that hose didn't have any kinks or pinches in it, and that hose was completely clear from one end to the other. Again, this does illustrate why it's important not to play the blame game, because we did actually install these two hoses wrong. They should have gone down and then across rather than just straight across, which is why they were pinching. Now, I wanted to verify that the bypass valve was actually working, and so what I did is I lifted up the car. This thing's pretty difficult to access, so I duct taped my phone to the steering column and then started the engine. And what you can see is the bypass valve is completely closed, it's against its stop. And then as you start the car and you create a vacuum within that intake manifold, well, then that bypass valve opens up. And then I put the car in fourth gear. Again, it's lifted up, it's just sitting there stationary, and I floored it in fourth. And so you don't have a bunch of load, but you've got the wheels in the air spinning. And so you can see briefly, as I floor it in fourth, that bypass valve starts to close. And then once I let off, then it opens back up. And then as I turn the car off, well, you can see the bypass valve once again closes once you have atmospheric pressure enter that intake manifold. Now, I don't know what this bypass valve actuation is supposed to look like, and in certain scenarios it did seem like its actuation was pretty slow. So I'm still operating under the assumption that something is wrong with this bypass valve, and so what I did is I reached out to Fab9. So Fab9 is a shop that has done a lot of work with these Edelbrock Supercharged Miatas, and they've got a lot of experience with them, so I sent some of my data logs to them to have a peek at. Then I learned more bad news. So my air-fuel ratios were a bit wonky, and this was something that I was actually wondering based on my fuel economy. And before you leap at me and say, Jason, of course a supercharged car is going to get bad fuel economy. Hold on for a second, hear me out. Fuel economy is a function of how much power you're making and how efficiently you're making that power. So this thing isn't making all that much power on a relative scale, around 200 horsepower at the wheels. So I wasn't expecting to see fuel economy numbers as low as I was. And this is partially explained by the air-fuel ratio. So while the system was targeting under boost an air-fuel ratio of about 11.4 to 1, what it was actually seeing was about 8 to 9 to 1 for the air-fuel ratio, sometimes as low as 7 to 1 for the air-fuel ratio. And so what does that mean? Well, it's how much fuel you're injecting. So stoichiometric, the ideal air-fuel ratio, meaning you burn all of the fuel and all of the oxygen in that combustion chamber, that's an air-fuel ratio of 14.7 to 1. So when you're under boost, you're gonna run rich for several reasons. It helps prevent knock, it helps you make a little bit more power, and it keeps your combustion stable. But you don't wanna run too rich. In that scenario, you start to waste fuel and you start to eat up your catalytic converter. So essentially what's happening when this thing's running a 7 to 1 air-fuel ratio is it's like injecting one injector in the cylinder and burning all that fuel, and then taking the same amount of fuel that injector's injecting and just dumping it in the exhaust and letting your catalytic converter deal with it, which is not wise to do, and it's obviously going to be terrible for your catalytic converter. One piece of good news as far as fuel economy is concerned, on the drive down to Humble Mechanics shop, I got 35 miles per gallon, and on the drive back, I got 31 miles per gallon. So it actually is possible, if that bypass valve remains open, to get solid fuel economy even with the supercharger installed. Now again, air-fuel ratios, that's a tuning issue, so I wasn't super concerned about it. And this was the point where I actually did those acceleration runs that I was talking about at the beginning of the video, where I found that it was slower after putting the supercharger on than before. And so I thought, well, there's no point in putting it on a dyno if I can't actually get boost. I need to actually identify what the problem is before going to that step. I went back and looked at the installation footage, and putting this supercharger in was a challenge. So, the actuator for the bypass valve got bumped, it's getting touched, maybe it got bent in one of these scenarios. Also, I hit myself in the eye with a zip tie, so maybe I just wasn't seeing clearly. Wear eye protection and, hold the end of a zip tie when you're cutting it. So that's where I was at. I was pretty much ready to give up at this point. I figured there's a mechanical issue with the supercharger. I'm gonna have to send it back into Edelbrock to get it fixed. Then it comes back. The car's gonna be out of commission for a couple weeks. Wasn't really looking forward to that. But I decided to give Brian at Fab9 one last call. One of the interesting things that would happen is when I'm in 4th gear and I floor it, say I'm at 5,000 RPM and I floor it, I don't get much acceleration. And I was assuming that this was a result of the bypass valve acting as some form of a restriction. And so the revs would slowly increase to maybe 6,000 RPM, and then I'm flooring it, accelerator pedal is 100%, and yet it's not accelerating. It's just sitting there at about 6,000 RPM at whatever speed that is. And so Brian at Fab9, he asks me, well, what's your throttle position? And what a beautifully obvious question, which is so easy to go back and say, duh, Jason, why didn't you look at that? But I simply assumed that if my accelerator pedal was at 100%, well, surely my throttle pedal was at 100%. And it was not. I misunderstood bypass valves, so I thought this could create a restriction in the system when really it cannot. So these supercharger rotors right here are always trying to create boost. And what happens is when your bypass valve is open, you no longer have a seal between the top and the bottom. So it takes that air and it just forces it back around and it recirculates. And you're never able to make boost as long as both sides of this compressor are connected. So when you close that bypass valve, now you've sealed off the top section from the bottom section. So when you force more air below, you build boost and then you make more power. So if you're not seeing atmospheric pressure in this entire system, it has nothing to do with the bypass valve. Instead, it is because your throttle is not fully opening. So I took my computer and I plugged it back into data log, and what did it show? Well, when I floored it in 4th gear above 4,000 RPM, while the accelerator input was 100%, the actual throttle position was about 33%. mind-blowing moment. So this explains why I couldn't get much acceleration in fourth gear, because that throttle pedal was acting as a restrictor, and it also explains why I couldn't get any boost, because the throttle pedal was preventing the bypass valve actuator to actually get enough pressure to close. And without that bypass valve closing, I don't get any boost. Now, I don't know why it's doing this, so I'm not going to speculate, but to me, accelerator pedal position at 100%, throttle pedal position at 33%, that sounds like a tuning issue, not a mechanical issue. So in my mind, we are back. So Fab9 sent me a calibration file and I put it on my car, and holy moly, what a difference. So not only is low speed drivability greatly improved, but also my throttle position now much more closely matches my accelerator pedal position. And so the no boost issues are gone. Whether I floor it at 3,000 RPM or 5,000 RPM, I have boost and I can continually go through the gears and maintain boost as I shift. So it is dramatically improved and I'm very happy with the tune that is now on the car. The good news is it's fixed. What I thought was a mechanical issue with the bypass valve ended up being a tuning issue with the throttle valve in certain scenarios. Now, sometimes with these types of videos, folks get mad and they say, why are you showing us all of this nonsense? Get to the driving, get to the dyno sessions. And then there's two major points I kind of want to make here. First of all, this is not a project car channel. This is intended to be an educational channel, and occasionally project cars happen to be the tool in which to teach something. And that was certainly the case here. And so, you know, you learn things when you don't understand things and you try to figure it out. And I genuinely find as much joy diving through these data logs and trying to figure out what's going on with this car as I do actually driving it. And maybe that's because I'm broken, but I think there's a lot of value in looking at when things go wrong and then trying to figure it out. I don't think YouTube needs to be this platform where we all pretend, we know everything and nothing's ever going wrong. And so in these scenarios where something's wrong with my car and I don't understand it, it's very revealing to me, how much I still have to learn about cars. And so I feel there's a lot of value in content like this. It has been 13 days since this supercharger went on, and only today has it actually started working properly. So I am hugely appreciative to Brian at Fab9. I will include a link in the video description to his tune if you're interested in supercharging a Miata and doing the similar thing, or if you already have one of these supercharged Miatas. And so next I will finally be getting into the dyno run before and after, the acceleration pulls, and a proper test drive, now that the supercharger is in working order. Thank you all so much for watching. If you have any questions or comments, feel free to leave them below.